2017, Paper 1, Question 3, Differentiation. So here in 3a, we were asked to differentiate the polynomial a third x squared minus x plus 3 from first principles. So it's really important to remember that we can't just use the general rule and differentiate because we'll only get the minimum marks there. We're asked to do it by first principles. So what we want to do first of all is to take our given function, f of x, and we're going to equate f of x to a third x squared minus x plus 3. Our second step then is to get f of x plus h. So wherever there's an x, we're going to replace that with x plus h. So it's always important to use brackets here when subbing in the x plus h, because often students will just add on a h to wherever there's an x without using brackets, and that's where all the problems begin. So again, it's minus x, so instead of x, we're putting in x plus h in brackets, and then it's plus 3. So there's no x there with the 3, so it just stays as 3. So before we go on to the next step, we want to simplify by multiplying out our brackets. So we have x plus h squared, so that's x plus h multiplied by x plus h. So that gives us square the first, x squared, multiply the two terms and double it, so that's x by h and then doubled. And then square h, which is h squared. And then it's minus times x plus h, so that's minus x minus h plus 3. So now I'm going to multiply out the 1/3, so that's a third x squared plus 2 over 3 xh plus a third h squared minus x minus h plus 3. So our next step then is to take the first step and the second step and subtract them. So in other words, f of x plus h minus f of x. So again, making sure to use brackets here when subtracting. So we have a third x squared plus 2 over 3 xh plus a third h squared minus x minus h plus 3 minus, and again, using brackets, a third x squared minus x plus 3. So again, if we forget to use our brackets, this is where our signs will go wrong and we'll end up not cancelling the correct terms. So, just go back there. So that's a third. So that should be a minus x up there. So that's a third h squared minus x minus h plus 3. So then minus a third x squared, and then minus x is plus x, and then minus 3. So now what we want to see is there any terms that we are going to have the same but opposite sign? So we do. We have plus a third x squared minus a third x squared. And then we have minus x and plus x. And then we have minus 3 and plus 3. So then that will leave me with 2 over 3 xh plus a third h squared and minus h. So our next step then is to go and divide by h. So I'm going to go on to the next page for that. So we have f of x plus h minus f of x all over h. So if I go back, we had 2/3 x over h plus a third h squared minus h, and that's all divided by h. So again, before I go on to the next term, I'm going to simplify. So I'm going to divide every term on the top by h. So 2/3 xh divided by h leaves me with 2/3 x. A third h squared divided by h gives me a third h, and h divided by h gives me 1. So the very last step then is to find the limit as h tends to 0 of f of x plus h minus f of x all over h. So in other words, we're finding the slope of the tangent to the curve as the distance between the 2 points gets infinitely smaller. So that means I'm getting the limit as h tends to 0 of 2/3 x plus a third h minus 1. So wherever there's a h, I'm going to let that equal to 0, and therefore that will give me my first derivative from first principles to be 2/3 x minus 1. So what's really important here is that you'll notice that in every single step I have been writing down f of x plus h, dividing by h, and then the limit as h tends to 0. If I don't write those terms that I've written in red down, I will actually lose marks. And again, I see that a lot. Students often just keep writing down the answers, but you have to keep writing down the left-hand side of these equations here. So all that red has to be written down every single time. So there was 20 marks going for that. So a lot of marks to lose if you just went straight to the general rule and just did bring down the power, take one away from the power. So it was a 20D mark question, so it was broken down into 5, 14, 17 and 20. So B then. So here what we're being asked to do is find the value of the derivative at x is equal to 0 for f of g of x. So basically I have to find f of g of x first of all, which basically means that if I look, I have f of x and I have g of x, and f of g of x means I'm inputting g of x into f and then finding the derivative. So let's start with that. So we have f of g of x. So wherever there's an x, I'm going to sub in the function into f of x. So we have natural log of 3x squared plus 2. So instead of x, I'm going to put in g of x, which is x plus 5. And that's 3x squared, which means I have to then square that x plus 5 plus 2. So in other words, here is g of x. And that's my input into my function in f of x. So before I can go any further, I need to simplify that. So I'm going to have to square the brackets first. So x plus 5 squared. So square the first term, multiply them and double it. So 5 times x is 5x, and if I double that, I get 10x. And then square the second term, so 5 squared is 25. And then that's plus 2. So now I'll multiply by 3. So always remember your BEMDAS rule, the order of operations. So we have 3x squared plus 30x plus 75, and then that's plus 2. So of course then that simplifies down to give me natural log 3x squared plus 30x plus 77. So now I have to find the derivative. So I'm finding the derivative of this function. So it's a natural log function. So again, we'll go to page 25 in our maths tables to see that if I differentiate a natural log function, that it's 1 over the function multiplied by that function differentiated. So the function within the function there is 3x squared plus 30x plus 77. So if I multiply by the derivative of 3x squared plus 30x plus 77, I get 6x plus 30. So in other words, my derivative is 6x plus 30 over 3x squared plus 30x plus 77. But of course, I'm not just looking for the derivative here. I'm looking for the value when x is a quarter. So that means I now need to sub in a quarter into that function. Sorry. There is. So wherever there's an x, I'm now going to put a quarter. So that's 6 times a quarter plus 30 all over 3 times a quarter squared plus 30 times a quarter plus 77. And if I simplify that, that gives me 3 over 2 plus 30 on the top line. And on the bottom line, I get 3 over 16 plus 15 over 2 plus 77. So then simplifying and putting it into my calculator. And again, just checking how do they want my answer. So really important here to always go back to your question and says give it correct to 3 decimal places. So I'm not writing my answer in fraction form, which would be 504 over 1,355. But instead, I'm writing my answer correct to 3 decimal places, which is, of course, 0.372. So that was only worth 5 marks. And starring it, because if we don't have it correct at 3 decimal places, we will of course lose a mark. So it should be 3 decimal places for our answer.